In this recording, we look at how to find the equation of the tangent to a curve at a specified point. And for a curve with equation y equals f of x, if the first derivative, dy dx, is evaluated at a specified value of x, it actually gives the gradient of the tangent to the curve at the point x, f of x. And once you know the gradient of the tangent to the curve, since the tangent is just a straight line that touches the curve at the point we're considering, we can then use this information to find the equation of the tangent to the curve at that particular point. So let's have a look at an example to illustrate this process. In particular, let's look at finding the equation of the tangent to the curve shown here. That is, the equation of the tangent to the curve y equals x cubed minus 5x squared minus 2x plus 9 at the point 1, 3. And the first step is to find the first derivative of y with respect to x, so dy dx. Now, when we're differentiating x to the power of some number, that is, when we have x to the n, then dy dx becomes nx to the n minus 1. So x cubed, the derivative of that will be 3x squared, and because all these terms are added and subtracted, we can simply differentiate term by term. So minus 5x squared, that will become minus 5 times 2x, which becomes 10x, minus 2x, the derivative of x is just 1, so that'll become minus 2, plus 9, the derivative of a constant is just 0. So therefore dy dx is 3x squared minus 10x minus 2. But we want to find its value at the point we're considering. So at the point 1, 3, we have x equals 1. So substituting that into our equation becomes dy dx at x equals 1. So that will be 3 times 1 squared minus 10 times 1 minus 2. And calculating that gives 3 minus 10 minus 2. So the value of the derivative at that point is minus 9. And what that's saying is that the gradient of the tangent to the curve at that point, sometimes written m for gradient, subscript t for tangent, the gradient of the tangent is minus 9. So what information do we have so far? Well, we know that the gradient of the tangent is minus 9. We also know that since we're looking at the tangent to the curve at that point, the point 1, 3 also lies on the tangent. The other thing we know is that a tangent is a straight line. So we're basically looking at a line which has slope negative 9 and which has the point 1, 3 on it. That is the situation with our tangent. And what is the general form of the equation of a straight line, such as this one? Well, the equation of a straight line is just y equals mx plus c, where m is the gradient of the line. So here right away we can replace that m with minus 9, so that the equation of the tangent is y equals minus 9x plus c. In this case, c is the y-intercept, but if we know the coordinates of a point on the line, then since this equation must be satisfied for every point x, y on the tangent line, we can then substitute in the x and y coordinates of that point to find the value of c and hence find the equation of this tangent. And we know that at the point 1, 3, that is basically saying x equals 1, y equals 3 is on that line. So substituting this in, we obtain 3 for y equal to minus 9 lots of 1 for x plus c. And from that, clearly, we can just rearrange that to find c. That becomes 3 equals minus 9 plus c. Therefore, adding 9 to both sides, we just get c equals 3 plus 9, which is 12. So that is the y-intercept of this tangent line. So finally, that means the equation of the tangent is going to be y is equal to minus 9x plus 12, subbing that in for c. So that is actually the equation of the tangent to the curve at that particular point. So the process we followed is we first found the derivative of y with respect to x. We then substituted in the x value at the particular point we were interested in, which gave us the gradient of the tangent. And then by substituting in the coordinates of our point, that allowed us to find the y-intercept c of the tangent line, and hence the equation for the tangent to the curve at that particular point. And the following graphic, which was generated by Wolfram Alpha, shows this tangent line. The original curve is in blue. We were looking at the tangent at the point 1, 3, which is that point there. So you can see the tangent touches the curve at this point, as required for it to be a tangent, and has the negative slope, as we would expect.